Hello everyone, we're going to start talking today. I'm going to give you an example of how to solve and set up a one-sample t-test for means. So here's the scenario. Many customers pay attention to stated nutritional contents on packaged foods when making purchases. Therefore, it's important that the information on the packages be accurate. A random sample of 12 frozen dinners was selected and the calorie contents of each one was determined. The box reported the calorie content was 240. Do the following data provide evidence to suggest that calorie content may be higher? Right, so that's our question. So this is an hypothesis test problem. So we're going to start off by doing phantom. So first, P, we're going to set up the different parameters. The first thing that I would do is I would go over here to the side, and in my stat menu, stat, edit, you can see I already put all the data into the list. So then I would do stat, calculate, one variable statistics, list 1, and I'm going to get some information. So based off of our list here, we know that x bar is 244.3. We know that S sub x, the standard deviation of the sample, is 12.38. We know the sample size is 12, and up here they're claiming that it's 240. So let's set up our hypothesis. So the null hypothesis is going to be that the mean is 240. The alternate hypothesis will be that the mean, now read the problem very carefully, it says, does the following data provide evidence to suggest that the calorie content may be higher? So the alternate is that it's more than 240. Don't forget to tell me what your mean is. So mu is the mean calorie content of frozen dinners. Right? A lot of people forgot to do this on the test, so make sure that you don't forget to do it from here on out. Next up, A, test our assumptions. So the first thing to consider is this a random sample? It says it's a random sample, so if we write that in words, we could say given we have a random sample of dinners. Secondly, second assumption, sigma is unknown. Okay, we don't know what it is. It doesn't tell us what the population standard deviation is. And the third thing up is we need to check normality. Now we only have 12 data points, so it's not enough for us to assume normality, and it doesn't say that it's normal. So then I need to go back to my calculator, and I would go back up to my stat plots, and you can see stat plot 1 is turned on. I'm going to do a box and whisker plot on list 1. So if I do zoom 9, there's my box and whisker plot. So nice little feature of the Smart Notebook. I can pull that over there, and I can say the box plot is symmetric with no outliers. So we can safely assume the distribution is approximately normal. Now, if you're going to do this, you should always draw the box plot. You should draw a quick sketch of the box plot to show that you did actually check it. Okay, so then next up, based on our assumptions, we can name the test. We're going to use a one sample t-test for means. Right. Now we can obtain our test statistic. Now you need to show your work on this, so you're going to need to know the formula. So the test statistic in this case, T, is going to be x bar, which is 244.33, minus the claim of 240, divided by the sample standard deviation, 12.38, divided by the square root of 12. Now, you can go ahead and plug that into your calculator and get the t-statistic that way, or you can do what I'm going to do next, which is I'm going to go directly into the test menu, go over to test, and you'll see number 2 is a t-test. We're going to do this based off of our stats, off of our data actually. We already have our data in the list. So if we go to data, the claim is 240, so we put in 240. All of our data is in list 1. The alternate hypothesis is that it's greater than, and then I'm going to draw it. And so here it comes, it's drawing it out. And it tells me that the t-statistic is 1.212. And it also then gives you your p-value, so we can go ahead and write that down, 1.254. And since I have it all here, I can drag that right over there, and I can put a nice little picture in there to show that it is normal. I can show what the t-statistic is, and I can also show what the p-value is all at one time. Okay, then we're almost done. Next up, we need to make a decision. Well, with that large of a p-value, we are going to fail to reject. And then finally, make a statement. So since we're failing to reject, we would say, since our p-value is over 10%, that's a really pretty high p-value, we fail to reject the null, period. There is insufficient evidence to conclude that a mean calorie content of frozen dinners is over 240 calories. And that's it. So now you have done a complete one sample t-test for means. You can see it's very similar to what we did before. We just changed a couple of things. The sigma is no longer known, so we're using a t-statistic. We're using our calculator to get us the p-value and the t-statistic value. But other than that, things are much the same. So hopefully that helps clarify some things for you, and I will see you next time.